All right, let's start with this first question here. It says, what is the percentage of water found in copper 2 sulfate pentahydrate? First thing we need to do is we need to find what the gram formula mass is for the copper 2 sulfate and what the formula mass is for the 5 H2Os. So we'll just write, let's get a pen out. We'll write CuSO4 and we'll write 5 H2Os. Keep in mind that this dot right here, it's a bad arrow, but that dot does not mean multiply. It means attached to. All right, so let's figure out. Copper, there's one of them. It weighs 64. Sulfur, there's one of them. It weighs 32.1. We'll round it to 32. Oxygen, there's 4 of them at 16 apiece. That's a total of 64. That's a total of 32. And that's 64. When we add all 3 of these bad boys together, we get 160 grams per mole. That's just the salt. Now let's do the water. I'll change my pen color. We'll move this over. We've got 2 H's at 1 gram apiece. That will give me 2. We've got an oxygen. There's one of them at 16. That's 16. That gives the water 18 grams per mole. However, there are 5 waters, so 5 times 18 is 90 grams per mole. Okay, if we want to know what the total of the entire thing, we have to add the 160 grams per mole and the 90 grams per mole, and we're going to get 250 grams per mole. Okay, so now once we know that the copper 2 sulfate pentahydrate has a total mass of 250, and we know that the copper 2 sulfate weighs 160 and the 5 waters weighs 90, we have the parts and we have the whole. So we're going to find the percent of water is going to equal the part over the whole times 100. You're getting this formula from table T. The part that we're looking for is always going to be, I don't know what happened there, is going to be whatever this is, percent of water. So this is the 90 is the part that I'm looking for. 90 over the whole Megillah, which is 250 times 100. And when we plug that into our calculators, we should get 36.1%, or simply 36%. Okay, for this problem, we need to find the percent of water, same as we did in the last problem, but now we have sodium sulfide, non-hydrate, so we've got Na, we've got 2 of them, they each weigh 23, we got a sulfur, we got 1 of them, it weighs 32, we got 46 here, and we've got 32 there, that gives us 78 grams per mole. Now we know that water has a gram formula mass of 18 grams per mole. And if you don't know where I got that from, look at the beginning of this video where I calculated 2 H's at 1 apiece and 1 oxygen at 16 apiece. But there's 9 of them. So 9 times 18 is going to give us the mass of the water. And that happens to be 162 grams per mole. And now, if we want to find the total, we add those 2 guys together. 78 plus 162 equals 240 grams per mole. And that's for the whole thing. Now we have to find the percent of water. And remember, we always write our formulas down. Percent equals part over whole times 100. The part that we are looking for is the 162, because that's the water. So 162 divided by 240 times 100 equals 67.5% water. Okay? All right, so we did 2 of that type of question. Let's move on to the next problem. All right, I got smart and enlarged it this time. So let's look at this problem. This one's a little bit different. In this question, they're giving us a 5-gram sample of the hydrate. That's the salt with the water attached. And it was heated and only 4.3 grams of the anhydrous salt remains. Anhydrous means no water attached. where the hydrate means there's the water attached. So let's draw it in a picture so you can really see what we're talking about. So we'll draw our little cloud, and in our cloud we have our barium chloride, and it's got waters attached. I have no idea how many waters are attached, but I'll just draw 3. It's just because we got waters attached. Why not? Now, it's telling us that this whole thing, let's get a pointer, this whole thing, the waters and the barium chlorides, are all going to weigh 5 grams. Now we're going to go and we're going to heat it up. And what happens when we heat things up is the water goes away. So we're going to end up with just the barium chloride. And they're telling us when it was heated and only 4.3 grams of the anhydrous, that means without the water, salt remained. So this thing weighs 4.3 grams. So they want to know what the percentage of water was in the hydrate. Well, first we have to figure out how much water we had. Let's get a blue pen. And if we started with something that was water and salt and it weighed 5 grams, this is, let's draw it this way. Salt and water, it weighed 5 grams. And then we had the salt only, and it was 4.3 grams. Then the water has to be these two numbers. Let's get rid of that. Can I get rid of that? Nope, I can't. Okay, it has to be these two numbers subtracted. So this is going to be 0.7 grams of water. Alright, so what I did was I just went to the next page and I rewrote it for us so we have it all nice and neat. Now, what we need to do is we need to find the percent of water in this barium chloride with a certain number. We don't know what number. I just drew 3 before, totally guessed, but we have to figure out what the percent of water is. So to do that, we need the part over the whole times 100. The part that we are looking for is going to be the 0.7 because that's the part that is water. So we're going to do 0.7 over the whole thing, which is going to be 5 grams times 100. And that's going to give us our percent water. And so my percent water is going to be 14% H2O. I'll make it in a little cloud because why not? Okay. Okay, this question is exactly the same as the last question. They gave us a hydrate. That's the one with the water attached, and they told us it weighed 2.5. They tell us that it was heated and only 1.7 of the anhydrous salt remains. So remember what hydrate and anhydrate mean. Hydrate means it has the water attached, and then the anhydrate means it doesn't. So this salt and the water weighs 2.5 grams. The salt only, that's the anhydrate, weighs 1.7 grams. So the water has to equal 0.8 grams. Okay, all I did was I subtracted these two because remember, let's use red, these two numbers, the salt and the water, make up this salt and water. All right, we need the percent of water is going to be the part that's water over the whole thing times 100. The part that was water was 0.8 grams. The whole thing weighed 2.5 grams times 100. That's going to give you your percent water. Squeeze that in there. Percent water is equal to 32% H2O. Can't write that enough. Always keep your things labeled and nice and neat. All right, in this one's a little bit more involved. You've got a 3-gram sample of a hydrated salt, and it's heated to a constant mass. And what that constant mass means is you've taken all of the water out, and they want to know how much of the anhydrous salt remains. Well, what we can do here is we can say that we have 3 grams of this Na2CO3 H2O, and we need to figure out what the percent of water is in that 3-gram sample. If we could find the percent of water, you'll remember that percent always has to add up to 100. So if we have the percent of water, we will also have the percent of Na2CO3. So let's figure out what the percent of water is first. Hopefully this works. All right, so here we have it. We've got Na, there's 2 of them at 23 apiece. We've got C, there's 1 of them at 12. And O, there's 3 of them at 16. So I multiplied them all out, and I add them all together, and I got 106 grams per mole. And the water, there's only one water, so we know that it weighs 18 grams per mole. Right? There's only one water here. So if we want to find the percent of water, we're going to take the part that is water over the whole thing times 100. The part that was water was 18. The whole thing is 106 plus 18, which equals 124 grams per mole. Remember, the whole thing is the water and the salt. So we have 124 grams per mole equals the percent of water. And I'm squeezing this in here. Hopefully you'll see it on the screen. I got 14.5% is water. All right, well, if 14.5% is water, then what's the percent of the salt that would be there? Remember, these percents have to add to 100%. So this has to be 85.5% salt. All right, now let's go to the next page, keeping in mind that we had a 3-gram sample. Okay, I rewrote it on this page so we have it. Well, they're looking for the part that is the anhydrous salt, only the salt, no water attached. So we need 85% of 3 grams is equal to what? So 85.5% of 3 grams gives us 2. Oops, I need a pen that writes 2.565 grams of salt only. Now you could figure out how much water there is by either taking 14.5% of 3 grams and getting a number, or you could take 3 grams and subtract 2.565 grams from it, and you'll find out how much water you have. And if you did the math, you will find out that it is 0.435 grams of water. Okay, question number 6. Here we are given a 5-gram sample of the hydrated salt. Oh, I'm on a highlighter. How cool is that? Okay, so we've got 5 grams of the CuNO32 with the water attached. And they don't tell you how many waters. That's actually what you have to find. They also tell you of 3.9 grams of the anhydrous salt. 3.9 grams of just the salt. That means anhydrous means no water is attached. If you have those two numbers, you can figure out how much water you have, and that happens to be 1.1 gram of water. And I got that by simply subtracting these two. 5 minus 3.9 gave me the water. Because remember, these two numbers, this number and that number, have to add, this number and this number have to add to 5 grams. Right, now, let's figure out what the N is. Now, the coefficients are always moles. And if you remember that coefficients are moles and that you know how to calculate moles from grams, we're good to go. So we're going to take our mole formula, mole, equals grams over gram formula mass, and we have the grams of water, and we have the grams of copper 2 nitrate, and we can figure out moles of copper 2 nitrate and moles of water. So let's start with moles of water. Let's label this water so we all keep things in the right places. All right, so we've got 1.1 gram of water, that's grams, over gram formula mass. Now the gram formula mass of water is 18. You should know how to calculate that at this point. I've been doing it in the last 4 problems, and also we have it on other videos. So 1.1 divided by 18 gives us 0.06 moles of water. Now we have to figure out the moles of the copper nitrate, copper 2 nitrate actually, okay? So we're going to do moles equals grams over gram formula mass for this one, and we're going to have 3.9 grams over the gram formula mass of copper 2 nitrate. So I went ahead and I calculated the gram formula mass of copper 2 nitrate, and then I put that gram formula mass into the mole formula, grams over gram formula mass, and you can see that right here. Let's get a red pen. Okay, and 3.9 divided by 188 gave me 0.02 moles of copper 2 nitrate. 3.9 grams of CuNO32. Let's figure out how many moles that's going to be. Moles equals grams over gram formula mass. Moles equals 3.9 over the gram formula mass of copper 2 nitrate. Okay, so I went ahead and I figured out what the gram formula mass is for copper 2 nitrate, and we got 188 grams per mole, so I'm going to put that down here. Remember, that's grams. So then moles is going to equal 3.9 divided by 188. And I got 0.02 moles of CuNO32. Now, if you think about that, if these mole numbers are the coefficients, I have 0.02 CuNO32, and I have 0.006 moles of H2O. Well, these two numbers are not whole numbers. Let's get a highlighter, right? So if I take and I divide both of them by the smaller of the two, which happens to be the 0.006, I can make them into whole numbers. All right, what I'm going to do on this page is I'm just going to simply rewrite this information that we have from the previous slide so that you can see it. And we have now a mole ratio. And if you recall, the coefficients that are in front of these formulas are mole ratios. So that N, which is right here, I'll write it in blue so we have it, is actually this number. Okay, so I'm going to write it. So we have 0.02 moles of CuNO32, and we have 0.06 moles of H2O. Here's the problem. We cannot have these numbers, I'm going to actually underline them in green, we cannot have those numbers be decimals or fractions. We have to have them as whole numbers. So what we'll do, the easiest way to do this is to take the 0.02, which is the smaller of the two numbers. Okay, so we have two numbers here. We have 0.02 and 0.06. Take the smaller of the two numbers and divide both of these coefficients by that smaller number. So 0.02 divided by itself is going to give us 1, which tells you have 1 CuNO32. And if I take the 0.06 and divide it by 0.02, which is the smaller of the two numbers, you're going to get 3. And that means you have 3 waters. So the N, which happened to